Awesome. So thanks everyone. As mentioned, I am Jacob Kranzler. I am a sales engineer here at Snowflake. Also have Joe Brooks on the line. He is an account executive. I specifically work in accounts on Colorado and Utah. Joe based in Utah, myself based here in Denver. We wanted to give a little presentation just around what Snowflake is. Kind of a lot of hype, a lot of FUD, a lot of negative and bad, good press kind of in the market that we've seen. So post IPO, I just wanted to let everybody kind of know what it is if you're not familiar, as well as some of the features we have that are kind of true differentiators, and then hop into the product, kind of do a quick little demo within there. I think for, this is a small enough group where if questions come up, please feel free to let me know. We can answer them in real time versus me just kind of pounding slides at you guys for a while here. So without further ado, I will jump in. So where Snowflake started. So we were founded in 2012 by two Oracle veterans. They actually kind of brought the idea of Snowflake to their senior management at the time. Weren't really interested, kind of cannibalized what they were already working on with their own solutions. With that, they kind of took it on their own, went into stealth mode for a few years. Began as kind of the first data warehouse in the cloud, only in AWS. It was US West 2 at the time. Then kind of as time went by, started to grow the customer base, started to get some eyes of kind of angel investors. And then up until, the recent months here where we have IPO'd and now sitting around 4,000 plus active customers. Switching from kind of the data warehouse built to the cloud to the new terminology of the data cloud. So some progress there. So how Snowflake is different, I guess, is how I like to start things is one, the separation of storage from compute, as well as the separation of compute from compute. So that is much different than legacy databases, SQL Server, Oracle, Teradata, Netezza, all kind of having either separated maybe storage, but the compute's linked. So if you need to scale storage, you also need to scale compute. Or, if you're scaling compute, then you're going to get a bigger kind of hard drive attached as well. So Snowflake, we are cloud agnostic, feature parity across Google Cloud, AWS, as well as Azure. AWS being the first, Azure second, and most recently Google Cloud. So wherever you are in terms of cloud, we're around 23 regions at this point. So how it works, storage in the back end, immutable micro partitions, that's kind of how we store the content. We then have these multi-clusters kind of going around this rainbow feature. So that is the ability to separate load from transform, from visualization, from data science, all on their own separated compute nodes, all hitting the same data while maintaining ACID compliance. And then the top kind of brains of the operation being really the software behind it, that cloud services layer. So if you're in AWS, if you're in Azure, Snowflake looks exactly the same. You're not billed by AWS or Azure, although we are purchasable through some of the marketplaces.
Hey, Jacob, I have a question on that that I've been wondering. Cloud agnostic, but does that mean just like you're running on all the major clouds, or can you work on-prem? Do you work like in Ollie Cloud? Do you work, how does that?
So only on these three clouds, I guess, at the point. I know Ollie Cloud is kind of big and up and coming. Maybe that would be like a fourth, but at this point, you would need to be in Azure, AWS, or Google Cloud. We spin the account up. You're not spinning up EC2 nodes of any type. So you just tell us what region, what version you want. We just create the account on top. So where that works is if you're already in AWS, US West, and you already have S3 buckets built out, we usually put your Snowflake instance there. There's no egress charges from the cloud providers, but no on-prem solutions, strictly in the cloud, kind of delivered as a service.
Thanks.
Yep.
And to add to that, I was going to say we can fail over. I was just going to say we can fail over, fail back between regions and between clouds, but we are always running on the hardware of one of those three clouds. So the performance is actually a little bit different, kind of agnostic. It's a little bit different region to region and cloud to cloud.
Thanks, Joe. Yeah, so as mentioned, kind of the global data mesh. So we have users that have accounts in AWS as well as Google. And as Joe mentioned there, kind of the ability to have a complete production environment in AWS with a failover in Google. So in case some catastrophic event happened, we could always fail over to a complete separate provider in a complete different region to maintain uptime. So we have clients with accounts across some AWS regions, Azure regions. We have clients with accounts in every provider, and then accounts just sitting in one region, one provider, and that's all they need. So some flexibility there. Can create an account in any region. If you're not loading data or running queries against it, it's not going to cost you anything. So how we scaled over time, now looking at about 1.3 million total Snowflake users logging in across the 4,000 customers, over 250 petabytes under management across the three, 89 petabytes being scanned daily. So that's like table scan type records, and then 515 million jobs queries ran per day. So just kind of a NASCAR slide here, just showing some of the customers that we work with that are referenceable, with the list kind of growing each day. So then just take a step back, how can Snowflake help our customers, others looking to migrate to a cloud data platform? We start with that mentioned kind of new architecture. So on the left-hand side, that's kind of where we first started with relational databases, shared disk, single cluster. We have maybe some of our loading. This is more of like an Oracle, Microsoft SQL. Your database is set at 1 meg or 1 terabyte. If we need to scale that, we're also going to scale compute alongside it. Next, coming with like Netezza, Teradata, Hadoop, shared nothing. So your compute's attached to your storage. Your compute cannot grow, your storage cannot grow. If they grow, they must grow together. We must move the data to, another version, another scale up, maybe another virtual machine that's larger. So with Snowflake, independent storage, independent from compute, compute independent from each other. We can scale up to 128 node compute and touch a 1 gigabyte database. We can have a petabyte of data only using, a single node if that was for any reason. So then to kind of get into some schematics, what we see like the quote unquote modern architecture here is we have ETL coming from OLTP applications, third-party data. That's piped into our warehouse, but the warehouse can't support JSON, semi-structured, Parquet, IoT streaming. So we stream that into a data lake. That then kind of complicates things for data scientists. They're spending a lot of time grabbing data from multiple sources, and then also spinning up kind of data cubes or data marts outside of the warehouse to then meet our different kind of use cases. So where we see Snowflake is kind of that single source of truth. Since we can scale storage infinitely, as long as the cloud has space, and then as well as the compute clusters, we can bring in that IoT, that semi-structured, which we'll definitely dig further into. But OLTP, enterprise, third party coming in, and these gear icons being that separated compute. So we have a single icon here that's handling all the loading. So we're loading our data. No longer do we need to load data at like 9 p.m. at night, so we're not interfering with the BI workload for the day. We can load data at the same time. We're running visualization, we're running data science models, workloads, sharing data, each on its own separated cluster, while maintaining kind of ACID compliance on that single data source in the middle. So what this introduces a little bit is the up arrow here. Within Snowflake, our compute is within t-shirt sizes. So what we have is from extra small all the way up to 4XL, releasing 5XL and 6XL soon for really large workloads. Although we see a lot of clients kind of stick to the lower ones. But what that is one server, one node per kind of t-shirt size, doubling as we go. So we see here a data science workload. If we knew it was going to be large for the day, we can scale from a single node up to 128 nodes and then back down. And then the side-by-side is the multi-cluster warehousing. So as queries come in, this handles concurrency. So we're able to handle queries as a queue. We have 10 queries on the single warehouse, and 11th comes in, not enough processing. instead of queuing that query and waiting for one to finish, we actually spin up without any manual effort another warehouse to handle that workload, continue to scale all the way up to 10 of those warehouses to handle hundreds, thousands of concurrent queries as they're coming in. So how do we see clients kind of migrate to Snowflake? Just a few best practices. So we typically suggest scoping out kind of initial workload. That is, finding a single item to work on versus a million to kind of run that first test, and then start with our free $400 trial we offer. So anybody can go on the Snowflake website, spin up a $400 free trial in their cloud and region of choice. I think a second big one is to determine how we want to move the data into Snowflake. So whether that's one of our vendors, whether that's through a Snowflake solution, like copying into from Blob, which I'll go into, that's kind of a next best step. What do we want to test? How do we want to get it in? And then another big one is ELT over ETL. So extract, load, then transform versus extract, transform, and load, just because that power of Snowflake, we can have the loading on its own as well as the transform on its own. Those both can scale at their own pace. So we see a lot of clients landing data in raw, using something like dbt or scheduled SQL and tasks to kind of then transform that data into a modeled or conform type. So isolating the workloads as mentioned, so that compute separation. Don't forget the connectors, ODBC, JDBC, Python, Spark. Make sure we know what we want to use against Snowflake. The connectors are easy to download, but sometimes we hit some hiccups if we don't have the driver yet downloaded. And then, gather any SQL scripts and DDL in bulk to kind of work smarter, not harder. Snowflake is anti-SQL compliant, but with Snowflake, we don't have items like primary keys or, indexing type functions. So just a little bit of script tuning around there. Where I say do it in bulk is usually we can get them all into a Sublime, run some regex, and kind of erase some of those syntax that won't work in Snowflake in bulk versus doing it one-off as we're running the queries. So how do you get data into Snowflake? So Snowflake, naturally, we can bulk load directly from blob storage. So S3 buckets, Azure Blob, or GCS. That is just using copy into statements from that blob. We can also stream data into Snowflake through our Snowpipe feature, and that's using SQS notifications on S3. A file lands in a bucket, it kicks a notification to our Snowpipe feature, we ingest that. Other is a lot of the big data pipeline providers I'm sure most of you are familiar with, Matillion, Fivetran, HBR, some open source ones starting to gain some steam as well. Any of these have native kind of Snowflake connectors with bulk load functionality. So if there's one in place, usually we'll have a client use that already, or we offer kind of POCs on the actual website through our Partner Connect, where you can spin up a click 14-day trial or a Fivetran trial with just clicking a button. So then kind of how can you model data in Snowflake? So this is kind of where, data lake and data warehousing kind of come in as one, and that's kind of where we're seeing a lot of conversation. The Fivetran CEO mentioned it recently, is like, if you're going to build a data lake right now, like, is there really a reason to? So we have a lot of clients that load all their data just into kind of a raw database, exactly as it's coming in from OLTP, exactly as it's coming in from our IoT machines. Those are then kind of making their way to the right, whether this is scheduled SQL tasks to do the modeling. What we're seeing most popular right now is dbt being handled for a lot of the movement of the data. So we're constantly landing data in raw. We're setting a Snowflake kind of CDC on those raw tables, and then we're running transforms to push it downstream, flatten it out for visualization, model it in some way for data science, whether we're using, data frames against Snowflake, pulling the data from this model DB into your data frames. And then the one here reference being kind of the static data not changing, but we see a lot of this land in raw. Maybe it lands in conformed as kind of like a middle, or just raw to modeled, where we're constantly streaming data over to the right side. So then once the data is in Snowflake, what can you do with it? How can you consume it? So pretty much any visualization tool on the market can connect to Snowflake, most of them having their own connectors. Tableau, Power BI recently enhancing theirs, Sisense, Sigma, some of the others we work with. We do have our own kind of visualization tool within Snowflake based on a recent acquisition we made of a company called Numeracy. So I'll show a little bit of that here in the demo. And then connectors and drivers usually handle kind of everything else. ODBC, JDBC, directly downloadable from the platform. That helps for MATLAB, R, Microsoft Excel, dbeaver being a big one that a lot of kind of SQL folks love. Native Python connector, pip install the connector, pip install the SQL Alchemy package as well. And then also the Go, the Spark, Node.js, and .NET available. And then for direct query, we have a worksheets tab. You can query within the product. We have a command line interface you can query from. And we do have kind of an open source accelerator add-on for those who will not get out of Microsoft Excel, maybe a finance or accounting use case. We can actually load data from Snowflake into an Excel sheet. We can actually edit that Excel sheet and upload that data back to the database. So for those that can't get out of Excel but do need to model or update data, it is now kind of a possibility with this kind of accelerator feature. So then to touch on some of the differentiators, myself coming from Microsoft SQL before joining Snowflake, a lot of my time was spent in this kind of column here: partitioning, indexing, non-clustered indexes, query plans with suggested indexes, vacuuming post-load, execution plan, the clustering, the backups. So a lot of this maintenance is kind of out the window with Snowflake. That's kind of what that cloud services layer handles for us. So we're not having to upgrade or patch, worry about that. We're not having to worry about taking backups or replicating data. Just the backups being a piece of the functionality called time travel we'll touch on. So the mantra of Snowflake being load your data and query the data. So one of the features kind of touched on the architecture slide is that ability to ingest relational data alongside semi-structured data. So that's the JSON, Avro, XML, Parquet, ORC. So we can ingest that data with what is called schema on read. So we're not running any pre-parsing functions to get that data in. We're actually just loading it into what's called a variant column. From there, using dot notation SQL to flatten out complex arrays into a relational form, joining those to tables, creating views over JSON data that makes it look completely flat. The end user has no idea that that's streaming in from an IoT machine from a JSON format. The next big one, and this is something I dealt with a lot in Microsoft SQL, is making copy. Yep.
I just going back to that, like, access of JSON data, because that is like one of the coolest things to kind of come out of, like, that I see in Snowflake. Like, you don't have to go through the process of structuring it beforehand. You just access the raw data based on how it is. The query optimization and stuff, that's your proprietary method, right? There's like some intermediate layers that you're creating that map the query onto the model data, onto the JSON data. Is that right?
Yeah, so how the data is stored is in kind of those immutable micropartitions. Every micropartition we store metadata on top of, so it knows the min and max values, the date ranges that the data might contain. So the query optimization is, if it's a 1 terabyte table and we have a date range in the where clause, we immediately filter out all of the partitions that don't include that date in it. So that's kind of how we can optimize the query. Instead of scanning a terabyte, maybe we're scanning 5 gigs. So I'll actually show how we can ingest some data and kind of flatten it out once I get actually in the product here.
So you're kind of, like, for other indexes that you might have within the JSON, you're kind of just creating new indexes. Is that kind of the core method that is optimizing?
So how that JSON itself is optimizing? Yeah, so it's loading into the large thing. We can't store as much metadata on like a JSON record since we don't have columns to really sort on. So yeah, whatever we can. Maybe it's like based on the date it was loaded is how we kind of know where to sort the records. So I guess, yeah, the structured data more query optimized, where the JSON query optimization is the ability to look at the joins, reorder some joins in the query at runtime if it makes sense to run it in a different direction, convert left joins to full joins. So we're doing that type of scan if the left join's not needed. So some different stuff happening in the brains, I guess, related to JSON and XML, I think probably less than you would see on a rigid structure set.
I have a question following up on data type or data structure types. Yesterday, unstructured data was announced. Do you have any idea what that looks like with respect to Snowflake?
Yeah, so that is, the unstructured data is kind of a big one. And what that is the ability to ingest video files, PDF files into the product. We create a link for that document, so you could click on it and actually produce what that was, a PDF. And then with that, storing metadata. So the size of the file, when the file was, what the name of the file is, if it's a picture, what the pixel size is, so that you can kind of store in your data catalog, data lake type solution, what images, what PDFs did we have from yesterday? I can run a query, that result set comes in, it gives me the metadata for each file that came in, as well as a URL where we could click on it and produce that file.
Oh, thank you.
Yeah, so that's kind of the, that was formally announced yesterday. So like I was saying earlier is we announced a lot yesterday, and now it's kind of my job as sales engineer to go learn it because everybody's asking about it. So we'll definitely have more information as it becomes more normal. We IPO'd, and since then we've gotten very limited access to what we're releasing to the public. So it's been a stretch just to even learn what we released yesterday. So then kind of jumping forward, the zero copy cloning, something we can do based on that unique architecture is the ability to spin up development clones of a table, a database in seconds. What it's doing is just copying the metadata to those micro partitions in the back end since they are immutable. So we copy production into dev. That can happen on a terabyte table in a matter of seconds. We can make updates to that copy without impacting what production is. You're not actually duplicating the data. We're only grabbing kind of new data or kind of new micro partitions to store as we're writing new data or deleting data, then we're storing that off. So that's something I'll touch on as well. But the ability to clone objects quickly in Microsoft SQL, we would always clone like a 1 terabyte database. To make that replication took a while, not minutes. So in Snowflake, we can spin up a replica, run an ETL job against it. If that looks good, all right, then we're going to run it against production. The next one is, due to that kind of storage uniqueness, is the ability to time travel. So on tables, we can set time travel from 0 days to 90 days. That will store a snapshot of every single transaction ran against that table for 90 days. So if I had it on a table at month end and I had it for 30 days, I can run a query and intersect between from what the table looked like on the first day of the month to the end of the month without having to manually run backups or, replication overnight to kind of store off snapshots. So something we'll look at, but the ability to restore data or duplicate data based on a certain point in time, based on the time travel setting you have on the table or database object. And then another one kind of due to that same immutable data store is the ability to share data. So a live copy of the data to a client without actually moving the data or duplicating the data. So the company I came from, S&P Global, we were a big kind of market data provider, stock data, fundamental data. We were dropping that data out to an FTP. Our clients would have to ELT that into their product and then make sense of it. S&P has actually now come onto Snowflake as a data sharer. They just live share that data directly to their customer. So as soon as a stock price lands in their database, it's immediately retrievable on the client's end versus waiting until it lands on the FTP, you download it, and then it gets ingested into your database. So kind of ability to do that cross cloud. So we have data marketplace vendors who replicate the data across all regions, live share, all of their content, regardless of the cloud provider or region there. Ability to revoke that access. If your contract ended with them, we can drop it. It is a read-only copy. So they're not going to be able to constantly be making copies, or any impact if they try to run a delete statement against your data. No impact there, being the read-only option. So how that's being used, one client example is Square. So Square actually is sharing data with what they call a marketing vendor called D3. So they're sharing data about the campaigns. D3 is actually then sharing data with the campaign results back to them. This used to be done via sharing CSVs via something like Box or email. This is now just a live data share back and forth between the two. This table's updated, shared over. They then update a table, share it back without actually copying, moving the data. Thus, it is live and quick versus having to move a terabyte of data or a gigabyte of data over, region to region.
This direct sharing is a pretty cool feature, Jacob. I think like that opens up a lot of options for a company that's kind of trading in data to provide that even as a service to a customer, right? Not to like just call out competitors, but who else is doing something like that? My knowledge is just Snowflake right now, right?
Yeah, so due to the uniqueness of kind of how we are able to share data, AWS has a marketplace, others have marketplaces, but it isn't that live read-only. There's still usually some movement of data from provider to end consumer. So this is, I think, with the move of like the data cloud, this is where Snowflake is putting a ton of energy. Companies like Experian, S&P, FactSet, replacing all that FTP. We used to dump data to clients on FTP. Now give us your Snowflake account. We'll just add you to the share. It's there instantly. We're no longer managing one FTP or any sort of ETL tool. At S&P, we built our own custom loader for clients because our files were so tricky to download. Now it's just a direct share. So they're having great kind of feedback on that. And then some free data sets on there too, is we have the biggest one is Star Schema COVID data set. So we have almost, I think at one point, like 60% of Snowflake customers had at least looked at it. And that is Johns Hopkins, Google, all sorts of others coming together to create that COVID data set. And as mentioned, it's updated throughout the day. It's immediately updated in your query. You're not having to run any ETL to get today's numbers or yesterday's numbers for a specific county. So then yesterday we had our big kind of data cloud summit. I think at some point we had around 40,000 people attending and made some kind of really big feature announcements. One being Snowpark, which is kind of a new developer experience, which will actually allow for additional data pipeline type workloads, data frame type workloads to be handled within Snowflake. So that's actually deploying like .jar files into Snowflake to then execute against the data versus running it through a JDBC driver, ODBC driver. So this one, there is a great kind of data cloud summit session on it. If anyone's interested, they are available on demand for the next 3 months on the Data Cloud Summit webpage. Python being the one everybody wants. That's the only question I've been asked is when's Python coming? It's on the roadmap. We started with Scala and Java initially to get it out. I think maybe perfect it because I think Python is the one that everybody wants, and definitely has been asked a lot. So you wouldn't be alone if you're wondering that. The next one, something I think we should have already had, is SQL-based stored procedures. So this is one that a lot of clients have been waiting for from a migration standpoint. A lot of people had a lot of T-SQL stored procedures, and how do you convert those to JavaScript, which was our current stored procedure language. So now we will have SQL. It won't be called T-SQL, PL SQL. I'm not sure what we'll name it, something with snow in the name, I'm sure. but this will give us cursors, for loop, if-while statements within a SQL-based stored procedure to really ease the migration workload from some of those legacy on-premise DBs, as well as just enhance the SQL functionality that kind of the product was built around. The third being a large focus on data governance. So we released or will be releasing object tagging. So at the column level, we can tag all objects that contain sensitive information, finance, accounting, and then we can run queries to see where is all of our sensitive data, what tables does that reside in, or begin to build kind of data lineage with maybe a data governance provider like Talend or Elation. And then the next two being row-based access. So to conditionally hide or display a row based on who's executing it, and then dynamic data masking to conditionally display or mask a column based on who's executing it. So row-based access, if you have a multi-tenant table across the database, but we only want to share certain rows with people, that is now the ability to create this row-level access policy based on the role that executes the query. You will get a certain result set. If you're maybe the account admin role, you can see the entire table. Similar with dynamic data mask. Oh, go ahead.
You got a couple of questions in the chat here. I don't know if you can view them or if you want me to read them off to you. So.
Yeah, sorry, I don't have them up. Take a look here.
Let me know if you get it, otherwise I can read them off to you.
Okay, so any worries about the crashing the engine, dropping jars to run within, or is it boxed off? So from my knowledge, it is kind of boxed off on its own machine. Before this ends, I will get I've watched one demo on it because we just got news of it. So I'll send the demo in the chat. I think it's about 30 minutes. Our kind of main developer walks through kind of what the vision is and how it works right now. So for Fitz there, I'll get back. For Rochelle, is object tagging smart or ML based? Right now, it is kind of manual. So we would create, every time we're implementing maybe on DDL, we're tagging certain columns as their sensitive data. So I think the roadmap would be to maybe make that more functional, but first we're just getting the ability to create some sort of tag on a column level.
Can I ask too, is there a summit session on the SQL-based stored procedures, if that's new?
Yeah, here, I'm making notes here and I'll make sure to get it out.
Thanks.
Okay. Yeah, great question. Sorry, I was ignoring the chat there. So then I'm going to hop in the product a little bit. We're going to just take a look at Snowflake first, load some CSV data, configure some warehouses, scale them up, scale them down, as well as look at that Snowsite kind of general dashboarding. What we're going to see, hopefully just that Snowflake is easy, scale up, scale down, scale out instantly, and we'll look at the connectors. What we're looking at is city bike data. If anyone's seen a Snowflake demo before, it's probably the same city bike data set. It seems to be our favorite. So these are bikes across Manhattan. A lot of celebrities like to ride them, it seems. Most Leonardo DiCaprio seen twice. So these are bikes, you pick them up at a station, you drop them off at a different station. That data is listed on their website, downloadable in CSV based on a certain format. So what I have is these staged out to S3 just for kind of easy ingestion from there. So kind of hopping in the product for anyone that hasn't seen it, this is kind of the UI for Snowflake. We have this top ribbon as well as these individual worksheets where the queries are. So much like other database solutions, we have databases. Next level down is schemas. And then within schemas, we can have tables, views, stages, file formats, pipes. We then have shares. So anybody that's sharing data to me, I can see the inbound as well as the outbound. The mentioned data marketplace are warehouses. So warehouses being those compute nodes, the isolation. So I have some dev, load, demo, various ones on my demo account. And then that worksheet tab will actually run the query. So in Snowflake, when you run a query, you need to define a role, who's running this query. That's for the role-based access control. And then we need to define either using kind of dot notation within the tables or in context saying, this role, this database, this schema, as well as this warehouse. So we would create a warehouse, load warehouse, starting on extra small here. And then we'll just go ahead and kind of look at that data sitting on blob. So we have kind of that same trips data from the city bike. And then let's take a look. So currently looks like about 1.9 gigs worth of data there across 850 files, about 2.3 on average in size. Let's create a general table. And then what we'll do here is I'm going to scale this extra small up to 2 extra large. I'm going to copy into our trips table from that S3 bucket. And then as soon as that's done, I'm going to scale the warehouse back down to extra small. So we scale up to this 32 node server, and then we're going to scale back to that single node server. So that ran, we can kind of see, looks like we loaded about, I think, 97.5 million records in about 17 seconds there on that 2XL, and then immediately scaled that warehouse back down so you're not paying for any additional compute. Then we can kind of just take a look at the data. This one being, very, very structured data, run kind of a general query. This is more to show the ANSI SQL compliance of Snowflake. Many of the functions you see across SQL, Oracle have been moved. One I like is we added the top functions. You can run select top 10. We used to only do the limit at the end of the query, being kind of the Oracle way. So kind of mending and bringing in the various syntax to kind of ease migrations for our customers. We can then create a view on top of some of that data and then select the view. One thing I like to point out here is we create what is called a secure view. So secure views are great to share data where we don't want to expose any of that underlying table data. So we ran a query against a secure view. Where that really shines is within the query profile. If someone was to go and try to understand how that query is running, all we get to see is secure view, trips view. But in the background, it's actually splitting joins across various tables, pruning certain tables as needed to produce that row set. But if you were to share that to another consumer, they wouldn't know the 15 tables that came to build the view you share with them. So then next, I was going to kind of touch on the zero copy cloning and the time travel feature. So we'll look at kind of creating a zero copy clone, use some time travel as well as swap. And then one of my favorites is with that time travel, kind of the fat finger drop mistake. One of my better career moments at my old company, I dropped a 1 terabyte table in SQL. That came with running the latest kind of backup and then transactional logs to get it as close to it as it was before I hit that drop statement. So once again, kind of setting the context, different warehouse for this different workload, we'll use the BI one. And then this is kind of where the magic of the cloning happens. So we have this 2 gig trips table. We want to create a clone of it for our dev team to run. So we run that clone. That happens in 1.27 seconds. And now we have a full copy, completely independent of that trips dev table. We then isolate the workload for the development team. We're going to keep them on their own development warehouse. And then we're going to run some kind of delete statements against that trips dev table. So I'm going to run an initial delete statement and then a secondary delete statement just to kind of help build the story for time travel. But what we would see as these execute is we'll see deletes, we'll see the tables begin to differ with no impact to that production trips table. So the first one went through, and then the second one. So in all, looks like we deleted about 85 million records. So shrunk that down to 240 megabytes. So our dev data team gets in there and we find that one of those delete statements should not have happened. Maybe this large one where we deleted the subscriber data. So what we can do is within Snowflake is that time travel. So we can create or replace a table based on another table at a certain point in time. I'm going to do it based on a statement. We also have before a timestamp or 5 minutes ago, we can offset the table 30 days. So you could have a query, a table with time travel, and you could run offsets every hour to see how it's changing if that was useful for some workload. So we'll go in, we'll see which statement deleted that subscriber data. Looks to be this one here. Grab that query ID, which is kind of associated to the single transaction we ran. We're going to plug that in here. And what this is creating a new table called tripsdev restore. We're going to clone tripsdev right before we ran this second delete statement. So now we create the restore.
Hey, Jacob.
Yep.
If there were lots of statements that were run and you wanted to roll back to that one, is it kind of an all after that as well? As in, like, the time that query was run, it'll restore back to that?
So in that situation, we would want to restore to the one before, but we could also restore a different table between and run some sort of, what was the difference that was deleted and add it back. So we can restore at any point in time. I could restore to the previous one. I could have ran 4 more delete statements and we could always get it back to what it looked like here or before. So
yeah,
the messier the transactions were, we would just have to kind of further work on the actual time travel statement. But so now at this point, we have kind of 3 different copies of the data: the trips production untouched, the trips dev, and then the trips restore, nearly back to what trips looked like just with that first delete statement. And then what we'll do here is we're going to alter the trips dev table, swap it with the restore table, which is what we want, and then we're going to drop restore. So this gets rid of the restore and gets us back to the trips table plus this first transaction that we wanted to run. And then we can run some general queries against that. And then, as mentioned, kind of my favorite one, just because I've been subject to it, is kind of the fat finger drop mistake. Maybe we're meaning to drop a trips dev table, but we just dropped trips. So now someone dropped our production table with that time travel capability. We bring that 2-gig table just back immediately. And if for some reason we wanted that restore table back, we can undrop that as well. Depends on, of course, if you have time travel enabled. 1 to 90 days would be kind of the limit of where we can drop or restore it from. Then kind of last but not least, going to touch on the JSON support. So the ability to bring in JSON without pre-parsing with what is called schema on read, and then the ability to join that to structured data, create views on top of it with, the raw type data always being that kind of nested array. So much like the first one, I've got some JSON data sitting on an S3 bucket. This is weather data. And what we can do before the data is actually loaded is this kind of like an external table function where we're just reading data from S3 blob as it lies. So this is the JSON files, 1 record per file. We just have some general kind of weather data, not too complex, but at least a little bit of structure there. So once again, we kind of set the context, what database, which schema, which warehouse. As mentioned, this can all be done here as well. We'll create the table. So the variant column is kind of the secret sauce here, what can handle that semi-structured data. And then we'll actually alter this warehouse, scale it up again, and then scale it back down. So with this one, we're going to copy the data from weather, and then we're just going to do kind of a quick transformation in the process. Is we're going to grab row 1 being the JSON, and then we're going to convert a timestamp from UTC to US Eastern. So kind of a very small little transform upon that load just to give us a timestamp in Eastern to then mirror to that city byte content. This one usually takes about 44 seconds, I believe. So while here, just wanted to show where in the Snowflake platform you can download JDBC, ODBC, Python being a very large one that we see use. Got the SQL Alchemy package as well as that general pip install. Node.js, Spark also being very popular. And then some connectivity diagnostic tool as well that was released. If anyone's having issues connecting through certain VPCs within AWS, if we've installed private link or some sort of security there. So with that one, we loaded, as we see 113 records, but this took 43 seconds. So the JSON took a little bit longer than what we noticed on the structured data set. And then we kind of get a list of all the files loaded and parsed out. Now we'll create another warehouse to kind of run queries against. So we see 113 million records. Let's take a quick look. So we have our timestamp, and then we have that JSON sitting in a column. And then this is kind of really where the power of that Snowflake functionality is now we're just going to run a query. The data is still stored in that JSON column exactly as it is, but using kind of this dot notation, we're able to actually start flattening it out into a relational flattened structure. So just kind of looking here is we have V being the column name, city, and then name is giving us the Adrian. And then we have v.city.country. So we go city.country, that gives us US. And then v.weather takes us down here. And then we're taking the first index of weather since there's multiple, index 0, and that's producing this snow section. So then it can get even more complex is where we begin to do what is lateral flattening. So kind of pivoting and parsing that JSON at the same time. So in the back end, we just have JSON sitting in actual storage, but we're able to, just using general SQL, no parsing functionality, begin to flatten it out, make comparisons. This is just kind of the weather in 2018. So it looks like, I'd prefer to be here in Miami. But then one other thing I like to show here is what is our caching layer. So within Snowflake, we have what is a query result cache. So any queries you run are stored in cache for 24 hours on the result set side. If the underlying data does not change, we can just grab that result set from the cache without spinning up a warehouse or charging any sort of compute. So we ran this query earlier. It's sitting in the result set cache. We see the warehouse doesn't turn on. So any user throughout the day, usually seen in BI reports, runs the same query, produces the same report. If that underlying data isn't changed, it'll pull it from the result cache. If it does change, it'll then go rescan the data and pull it up. So how we can see that is we look at the query and we see query result reuse. So that's 24 hours as long as the underlying data doesn't change. And then just kind of creating a little more complex of a secure view, joining our initial view we created alongside kind of this flattened out JSON using dot notation to grab wind direction and wind speed from some of the arrays within. And then one thing I also wanted to show is what is our new kind of worksheets GUI that we're releasing over time, and that's due to that acquisition of that company called Numeracy. So what this does is it gets us into a new look for Snowflake. So we have that same worksheets functionality. What it brought is the ability to create simple visualizations within the product. So this is querying that trips data we just loaded. So kind of trips over time, as well as some other general visualizations, not meant to replace Tableau or Power BI in any way, but the ability to create kind of general dashboards easily within Snowflake with just a general query being in the back end. So we run the query, and then now we also have this chart functionality where we can say maybe instead of day, we want it by month, or we want it by the exact date timestamp. And then we kind of adjust it on our dashboard and build it out in that regards.
Actually, that's really cool for, I would say, SQL analysts, for example, who want to sanity check their data as they're writing code. That's really cool.
Exactly. So with that, I think it gets cool in the worksheets tab as well. As we begin, every query you run will begin to expose that underlying metadata. So you can see the range of trip duration. You can see if your start and stop timer filled or if they have nulls. You can see min and max kind of on these latitude, min and max on the different bike IDs. So it does really begin to get a little more powerful. And one thing I like is now we have kind of a format query option to fix my nasty formatted SQL. I think I already ran it here. But it kind of formats it out, tabulates it in a nicer way. And then, yeah, you can create your chart. It'll automatically guess a chart. We have bar graph, scatter, heat grid, scorecard. Doesn't look like this query bodes well to either. And then where we're seeing a lot of value in it as we're beginning to build it out is our own account usage. So we share back 365 days of all things that have happened in your Snowflake account, every query that's been ran by every user. So the admins can begin to kind of create some nice dashboards to monitor Snowflake usage, spend, overall data load throughout time.
Are you planning to put, so on those dashboards, like having a alerting? Like
to
maybe
alert on top of?
Yeah, on top of a dashboard, like if your storage over time exceeds some values, like those sorts of alerting things.
So we have, I think we're looking to an alerting feature right now. The only way inside of Snowflake is to create like resource monitors, which can alert you based on if X person used X amount of credits this month. We can set quotas for each of the warehouses. So that's kind of there. I think that would be a great next. I know we have kind of a open source Snow Alert that can handle some alerting, but from what I'm hearing is eventually bring some of that into product. But I think that would be great, but unfortunately I don't think on the roadmap at this point.
Another feature that's a little bit deeper on that question, you know, when I start to see those summary matrix of tables, I think about tools like Great Expectations that can do like unit tests on data, you know, so like make sure that you don't get negative values that come in on a field, or and then do alerting. Like that's the more fine grained control, which gets to an open question, and that's currently in, you know, our data industry is just how do you put checks onto your data ETL?
It's almost like data quality. Yeah. Maybe something we could do. I think this is at least a step in the right direction where you can kind of click on a specific column and without running counts, you can see that there's 3 with this, you know, 17 distinct in this entire, and then actually giving you counts on each record that is coming in. So that is for anyone that's in Snowflake or anyone that signs up for a trial just to play around. This can be accessed via preview app. Eventually, this will be our mainstream replacement for worksheets. It's just not ready for prime time yet. Mostly, it's missing kind of the top pane and then some of the fine database objects. So slowly kind of continuing to enhance that before replacing this main worksheets tab. And that's kind of all I had.
Hey, Jacob,
yeah, any questions?
I have an admin question. So in organizations, who is typically owning the Snowflake instance? Is it the data team or is it IT infrastructure? Is it historic DBAs? Who's owning that? And then provisioning data warehouses and the resource monitoring?
Yeah, so that, I guess it varies account to account. We have some like DBAs who kind of own the instance. Within Snowflake, there is some roles. So we provide an account admin, that's like the top person. We suggest only a few have access to account admin. And then we have roles like security admin, which we suggest creating your role-based access control within. And then a separate sysadmin who we say would create the warehouses and the database objects. So we might even delineate some of those responsibilities. And then, yeah, with organization is that ability, if you have AWS West and you want to try something in Azure, you can come in here, pick a certain region, a certain cloud, hit next, you give it a name, now you have an account in Azure. So if you have data over there, want to receive data over there, it's that easy. And then, yeah, some general billing and usage throughout the day. A lot of clients who manage a ton of users, Okta integration, Azure AD to actually push down users versus manually creating them in Snowflake. And then kind of the history is great in terms of we'll share back, and an account admin could go see every query that was ran against the database, who ran it, did they run it from a driver or from the UI? So some cool admin features there.
So you showed in your demo that you created the data warehouse, or you spun up a warehouse, ran a query, spun down the warehouse. Do you have to have a certain admin level to be able to do that, or is that expected of analysts?
Yeah, so we typically have just some people that can actually spin it up or spin it down, usually like your power analyst. If not, we would usually have a warehouse. You get assigned a warehouse, it's an extra small, you can't scale it up. If you need to scale it up, maybe that's a JIRA ticket internally, or maybe that's an escalation internally, so that you're not given the keys of the castle to run up compute charges on bigger warehouses. So we have a lot of analysts that get one warehouse that's extra small. If they need anything more, they have to go through a DBA or some sort of formal process.
One question I hear coming up revolves around pricing. Do you have some suggestions for maybe various pricing models people could consider for Snowflake?
Yeah, so let's see, I think Joe had to drop. So this, what I think is great, so Snowflake is billed by compute per second. So each kind of warehouse, as we looked at, is considered a credit. So 1 credit per hour. This is 2 credits per hour, 4 credits per hour. It kind of doubles as you scale up. And then each credit can then be discounted with like a capacity purchase, which Joe could touch on. What I've seen a lot of kind of use is if someone's going to estimate it on their own before even kind of looking at Snowflake, Snowly has kind of a pricing calculator where you could kind of design your workload within. My role as a sales engineer when I'm working with prospects is to help build that out as well. And then I think, let me confirm, I know HashMap put out a good one as well, just to help with general estimation, that clients, you know, maybe want to spin up a trial, play around, but before engaging with sales, you want to just kind of make your own little calculation. There are a lot of good resources out there because Snowflake is a little different than, you know, Microsoft SQL, where you just bought hardware and that was your sunk cost from day one, and you just use it kind of till it exploded or something. So this HashMap one is great in terms of how many gigabytes do I have? How much is it going to grow? How often are we going to bring data in? How many dashboards are we transforming? So this is one that we've seen people have some general success with. And then, yeah, I think with that, I would say start a free trial, test a specific workload. From there, we have what's called on demand. You can put a credit card in and keep using it at kind of the list price to begin to scale your workload. And then we do also sell kind of capacity contracts that come with, you know, heavy discounting depending on your spend with the product. And that's where I wish Joe is still on here to kind of help me with there. But I would say start with the trial. If you're interested in, you know, estimating yourself, there's good tools, HashMap or Snowly, and then also engage someone like myself or Joe on the actual sales team if you're ready to begin a conversation at that level.
So I see you guys just got a FedRAMP ATO. How do you manage data sets for a customer who might have data that needs to be in a FedRAMP boundary and data that doesn't need to be? Would you separate out their data storage or data access?
Yeah, so FedRAMP being an interesting one, I believe we're FedRAMP on Azure Gov as well. I'm not even sure. I think there's might not have access in, but we have a specific like Gov or Fed type region where we have that FedRAMP classification. So we would have clients probably load that type of data into that solution. We also have business critical, which gives like HIPAA, PCII type compliance for that PII data. So where I guess it would be up to what kind of that data looks like and how the client would want it. If you want to ingest all your data into our FedRAMP certified type solutions, that would be fine. But you could also spin up a FedRAMP and then completely separate that from your data by spinning up an account in a different region for the rest.
Awesome, thank you.
Yeah. So then, yeah, for anybody that was running late, anybody that likes kind of free swag, Joe mentioned we're not positive what it is yet. I just threw the form at the end here. So because we're able to present here, thanks to Joe, we have some swag if you want to fill it out. A BDR won't call you on this phone number, I promise. So you're safe there. And then the street address and everything is just for the delivery of kind of that swag box. Usually give out some pretty good stuff there. And then I think I owe the Data Cloud Summit link for the Snow Park demo, which I'll get out here, and then the SQL stored procedures. So. All right, so any other questions I can kind of answer here?
Just one more. With scaling warehouses up and down, can you schedule that?
Yeah, so we have what are tasks within SQL. So we can create a task to run at a cron expression a certain time. Maybe you scale your warehouse at 9 a.m. and then scale it back down at like noon or something. So we can schedule tasks to alter those sizes. And then for any user that had privileges, they could go here and resize as needed. For those that didn't have privileges, when they tried to resize, they would just get an error that they're not authorized to do so.
Mitch Moore had a request
Okay.
to you. I'm sure you saw that in chat. So
yeah, Mitch, I will. I'll get you the details over.
I will say the SQL stored procedures are going to be nice. I helped a client debug some JavaScript stored procedure issues one time, and they wrote it like a JavaScript developer would write code. So it turned out how you would think. So.
Yeah. I'm no good in JavaScript, and I thought I was pretty comfortable writing stored procedures in Microsoft SQL, but I've yet to do a decent one on the Snowflake side, just since it has been JavaScript.
Awesome. Well, I'm gonna stop recording. Thanks, Jacob. This has been awesome. So.